Welcome to episode 1 of Tornado Theories, the series where we dig into the weird, the extreme, and the unexplained parts of tornado science without spreading misinformation. Every claim gets broken down, every assumption gets challenged, and every theory gets tested against real world evidence. And today, we're starting with one of the most underrated tornadoes of the entire 2011 super outbreak, the New Ren tornado. On April 27, 2011, the atmosphere over the Deep South was locked into one of the most extreme tornadic environments ever recorded. Wind shear, instability, moisture, and lift were all operating at near record levels. Dozens of storms were already producing tornadoes before noon, and more were developing by the minute. One of those storms moved into northeastern Mississippi and produced what the National Weather Service officially labeled an F3. But the tornado that touched down near New Ren wasn't just another rural Mississippi EF3. This storm was the precursor to the legendary Smithville EF5. And that matters. The environment didn't suddenly become extreme after New Ren. It was already there, which means the tornado before Smithville had everything it needed to be just as strong, if not stronger, than the one that came after it. And that's where the story gets interesting. The New Ren tornado tracked through rural areas with few structures and even fewer photographs. In the chaos of the largest tornado outbreak in U.S. history, this tornado slipped into the background. But the damage it produced did not match an EF3. In fact, based on the evidence we do have, the New Ren tornado was almost certainly a violent tornado, and may have matched or even exceeded the strength of the Smithville EF5 that followed minutes later. Let's start with the most extraordinary piece of evidence. While crossing Interstate 45, the tornado picked up a pickup truck and carried it for around 90 seconds as the tornado moved at 60 to 70 miles per hour. By the time the tornado released it, the truck had traveled 1.7 miles through the air. That is one of the farthest verified tornado car throws in history, and in 2011, it likely set the world record. A tornado capable of sustaining vertical motion for that long, while carrying a multi-ton vehicle, is operating in the EF5 wind regime. EF3 and EF4 tornadoes can't do this. You need extreme pressure deficits, extreme rotational velocities, and violent suction vortices, conditions found only in upper-end EF4s and EF5s. And remember, this wasn't even the tornado's peak. Even after the tornado weakened slightly, it swept 5 homes completely off their foundations in the Chapel Grove community. The debris was fragmented, shredded, and in some cases reduced to splinters. Lines of debris showed intense wind rowing. Streaks of material lined up with the wind field, something seen almost exclusively in EF4 and EF5 tornadoes. Wind rowing requires multidirectional tearing, suction vortices, and wind speeds well beyond the EF3 range. So why wasn't this tornado rated correctly? Because the National Weather Service never reached the area with the most extreme damage. Chapel Grove, the zone of complete destruction, was not surveyed. Not because the NWS ignored it, but because the 2011 outbreak produced so much devastation across such a massive area that survey teams simply couldn't get everywhere. That's not judgment, it's just reality. Now here's an important and rarely mentioned part of the story. The independent group Tornado Talk was actually the only team that managed to get close to the Chapel Grove area after the storm. They documented the damage and published a write-up, but their classification of the tornado as an EF3 was extremely controversial. Many meteorologists and damage analysts disagreed with their conclusion, arguing that the photos clearly showed EF4 to EF5 characteristics. But the rating was never officially upgraded, and because no federal survey was completed in the worst hit zone, the EF3 rating remained the default. Now let's look at the environment, because this is where everything clicks together. The same parent storm produced the Smithville EF5 just minutes later, one of the most violent tornadoes ever documented on Earth. The environmental parameters that supported Smithville were the same during New Ren. Extreme low-level shear, massive helicity values, high instability, deep moisture, strong upper-level support, violent inflow, and a rapidly strengthening supercell with a powerful rear flank downdraft. If a storm can produce one EF5 in those conditions, there is no reason it couldn't make two. In fact, the car-throwing evidence suggests New Wren may have been operating at violent intensity before Smithville ever formed. But here's where it gets fascinating. On April 27, 2011, we didn't just have one supercell wreaking havoc. There were multiple storms in the same area, all primed for destruction. While the New Wren-Smithville storm was tearing through northeastern Mississippi, another supercell nearby was unleashing its own series of violent tornadoes. We had the Tuscaloosa to Birmingham EF4, the Caldwell EF4, the Rainsville EF5, and even the Ringgold EF4, all occurring from a single supercell. This is crucial because it shows the atmosphere was set for chaos on a scale we rarely see. We had parallel supercells, each capable of producing violent tornadoes, all in the same region. The environment wasn't just supportive, it was maxed out, ready to unleash fury. When multiple supercells in close proximity start producing long-track tornadoes, it reveals something critical about the conditions. Looking back at the New Wren tornado, we need to see it in this larger context. The Smithville EF5 didn't just become violent on its own. The atmosphere was already churning out tornadoes to the east. This means the New Wren tornado, forming just minutes before Smithville, was likely tapping into the same extreme conditions. It wasn't just an ordinary EF3 in an extraordinary environment. It was a violent tornado in a place where that was the norm. Given the evidence we have, like record-level vehicle displacement and swept foundations, it's likely New Wren was not much weaker than Smithville at all. In fact, based on the car throwing alone, it may have been even stronger. So why revisit this tornado? Not to attack the NWS, not to call the EF scale broken, but to highlight something important. Violent tornadoes are sometimes underrated because of where they hit, how fast they move, or how chaotic the outbreak is. Some tornadoes never get the full investigation they deserve, and New Wren is one of the clearest examples of that. Based on the vehicle lofting, the home removal, the debris shredding, the wind rowing, the New Wren tornado checks nearly every box for EF5 level intensity. Even though it officially remains an EF3, the physical evidence points to something far stronger. So for episode 1 of Tornado Theories, the New Wren tornado becomes the first tornado we unofficially rank EF5. It's a reminder that tornado science is full of mysteries, overlooked events, and underrated storms. And that even during the most famous outbreak in history, one of the strongest tornadoes of the day still slipped through the cracks. Thanks for watching episode 1. Let me know in the comments what tornado you want covered next. Whether it's underrated EF5s, weird damage cases, or tornado myths that need to be broken down.